So under aerobic conditions, the pyruvate produced by glycolysis will be oxidized to acetyl-CoA using the enzyme, the pyruvate dehydrogenase complex, or PDC. This enzyme is a key transition point between cytosolic metabolism and mitochondrial metabolism. The complex consists of 3 subunits which require the cofactors thiamine, shown here as thiamine diphosphate, lipoamide, as well as FAD. You'll also notice that NAD is also required for the reaction to move forward. So the enzyme itself is highly regulated by both allosteric and covalent modifications. So the complex itself, if we look at this here, can be regulated allosterically by several means. First, it can be allosterically activated by NAD+ and pyruvate. Conversely, the dehydrogenase complex can be inhibited by acetyl-CoA as well as NADH. Product inhibition is very common as a regulatory mechanism, and high NADH would signal sufficient energy levels, therefore decreasing the activity of the PDC. The enzyme itself is also regulated through covalent modification or phosphorylation. And ultimately, phosphorylation will inactivate the enzyme complex and reduce the production of acetyl-CoA. The enzyme responsible for the phosphorylation of the pyruvate dehydrogenase complex is pyruvate dehydrogenase kinase. The kinase is regulated inversely to the dehydrogenase complex. Therefore, the kinase is most active when acetyl-CoA is high, NADH is high, and ATP is high. This will activate the kinase activity and phosphorylate and inactivate the pyruvate dehydrogenase complex. High levels of insulin, as well as increased levels of calcium, will activate a phosphatase, which will dephosphorylate and therefore activate the enzyme. As we talked about earlier, is the need for cofactors or coenzymes in metabolism. So a deficiency of which of the following cofactors would result in decreased activity of the pyruvate dehydrogenase complex? So we know from just a few slides ago, the correct answer here is thiamine. If we look again at this initial slides, thiamine diphosphate, shown here, is required for the initial step in the conversion of pyruvate to acetyl-CoA. We'll see later that biotin is required for carboxylation reactions, specifically reactions by pyruvate carboxylase or acetyl-CoA carboxylase. Vitamin C is used in collagen synthesis, but we're not going to talk about that in this course. And folate, we'll see in a few more weeks, is required for nucleotide synthesis.